Today I'm going to show you the Sonoff POW R2 device. So let me remove the label from here. This is the Sonoff POW Release 2 R2. Okay, so it works as usual with all IFTTT, Nest, Google Assistant and Alexa out of the box. But still I prefer to use the Tasmota firmware because I like everything in my house to be talking in MQTT, and I like using Node-RED to control everything through it to build the logic and the rules. So this is the packaging. Let's open it. So inside we'll find the user manual, the as usual quality certificate. This is not in English, this is in Chinese I think. So, this is in English. So this is the user manual. It has the wiring diagram also. So I'm gonna specifically use it for my water heater. A good idea, I can use this device for example, I can turn it on in a certain time of the day, and I wanted to heat the water once with one cycle only, and once it detects that the power usage is lower, is low, that maybe for example around 25 watts, something like that. So I'm gonna get the readings in voltage and in current, so I will explore with that. When is it on idle power with my heater, and when it is in active power. Based on the readings I can do some logic to turn it on and off based on the heating cycle that it does. So there is a button, I suppose this turns it on and off. And I suppose also it's used for whenever I'm going to connect the pins to program it to flash Tasmota firmware through Arduino IDE. So as usual you press on the button, then connect the USB. So let me disassemble it. So I didn't talk about the specs, so it takes up to 15 amps and it uses Wi-Fi. I think there is no RF. I don't need it actually. So let's disassemble it. You can see the diagram. It says from left to right the output load, and 2 ground, and input load, and 2 neutrals. It's got the, I think it's a mechanism for clipping the wires. Does it clip the wires or? Yeah. So I think I just put the wire inside, and while putting the wire I can just trap it with the, all these are like spring loaded buttons for clipping the wires. That's a good idea. Okay, let's disassemble the rest of the device. So it's quite simple, just a little bit pry it out here. It won't take a lot of prying out power. Okay, so where are the pins? Where are the pins? I think these are the pins. And they are labeled also. That's great. So let me focus here. So as usual, the one with the squared line, it's like VCC or I don't know what VDD stands for. Maybe you can comment on that. And TX, RX, TX, ground, and that's it. So I just need these 4 pins. I don't need the others. I think the other pins are used for voltage monitoring. Yeah, by the way, in the Sonoff wiki, it's mentioned that this is the most dangerous device of. Usually you don't need to connect it to mains to program it. You have to connect it to your FTDI board and take the power from the FTDI board. Don't connect to mains and program any Sonoff device. That's an advice in general. Let me disassemble that. So for this device specifically, when you connect it to the live mains and you try to program it, you are going to fry your PC, or you're going to fry both the PC and the FTDI board. The FTDI board definitely, but a high risk that you're going to fry your PC. So please don't do that. Just take the power from the FTDI board and also the serial connection. Okay, so I've disconnected it just for easily accessing all the elements of the board. So all the components. I think this is the ASP chip. Let's see which one does it have. Is it the 8266 or 8285? Let me zoom in here. So this one has the 8266 board chip. Okay, that's great. Now there are no other pins to access. Seems all of them are utilized for power monitoring. That's great. Okay, now let's connect it and flash it with Tasmota. So as usual, now this is my FTDI board, and I have the wires already set up before. I like to keep them ready all the time. The VC from right to left, the white, okay, let me connect it again. The white one is RX, then TX, then VCC, then ground. Okay, sorry, again, right to left. RX, let me focus here. RX, TX, RX, TX, VCC, ground. Alright, for the POW board, VCC is here. I like to keep it this way so I'll not have to put some tension on the wires. So it's the easiest way to program it. Now, as usual, just press on this button here and connect it to your USB port in your PC. Okay. Since the light is not blinking, so it seems it went into the flashing mode. That's great. Now I'll set up my Arduino to connect to ESP8266, and in the user settings I'll just keep the Wi-Fi config no SSID to Wi-Fi manager. This is the best setting. I like it a lot. And no SSID, so you can configure whenever you want, or you can just set up the SSID in advance. Sometimes it's better. So it's 8266, the out 1 MB 64K. That's all right. Everything is set up. Now I'll just upload the Tasmota firmware. So it's beginning to flash it. Okay, so you can see the progress bar is loading. That's great. From the first, I rarely make it out correctly from the first time. That's a good achievement. So now it's flashing. It will go up to 100%, and also if you unfortunately I have my FTDI board flipped upside down. I don't want to fiddle with it now. So there will be an LED green LED light that it will keep on flashing here don't know if you can see it. Let me see. I'll just show it to you. Oh, yeah. So this is flashing. That means it's programming correctly. It reached to 76%. Just a little bit more. It will go to 100%. Then I can connect to the Wi-Fi hotspot that will be advertised by this board. It went to 100%. So I forgot to mention, many times I do forget to mention that please change the project name to something unique. Maybe you can call it Sonoff POW R2-1, something like that. So it doesn't clash with other devices that you have at home. Alright, so it's done the flashing. This is also blinking. Now I'll connect to it through Wi-Fi and start to program. Oh, I forgot to mention about the relay. So it's a little bit bigger. You can see the rating is higher than 15 amps. It's 16 amps. It's great. Okay. Okay, so never mind the name here. Just it should be the Sonoff R2 POW R2 device. I just wrote the wrong project name. It's fine. So I'll connect to it now. I don't care. Fine. Now you will just easily reach the gateway IP from your phone usually, or you can just look up the gateway IP address from your phone settings and then browse it. It should be .1. The IP will begin with 192.168.4. whatever. Alright, so the Sonoff will be .1, and that's if it's in the Wi-Fi manager mode. Okay, now we'll have to configure the SSID. Oh, this was for my friend. Sorry, I'll pause here. Just, okay, so we're back in action. A good idea is just to keep your secondary Wi-Fi name as the Wi-Fi hotspot name of your mobile phone, in case your primary Wi-Fi goes down and you want to access the device and change the settings. And there is a way you can also scan for Wi-Fi networks and change the and connect the correct SSID that you want. So I'll just save it. Okay, I think it's restarting, so I'll just open it again. It's not restarting. It's already connected to my home router, so I'll just look it up in my router itself. So what's the IP? Did it come up? I think I just have to disconnect the USB and reconnect it again. It happens a lot. You just disconnect, reconnect, and it'll connect to Wi-Fi. I think it happens on the first setup. So it should connect. Yeah, it's connected now. 192.168.1.212. 192.168.1.212. Okay, good. Alright, I can turn it on and off. I can hear the sound of the relay ticking on and off. Good. But it's not set up correctly to Sonoff R2, so just change the configuration here. configure the module to Sonoff POW R2 and save it. So now it's set up to the correct device. You will see also there are the readings for the voltage and current, but I did not connect any device yet, so it will all be 0. And as per the Sonoff wiki, you need to calibrate the readings of the Sonoff POW R2. I'm not going to show it in this video, maybe I'll do it later, but I'm not really concerned to regulate it. I just want to use the figures to know if my heater is on and off. I don't mind for a few milliamps difference or amps difference or voltage difference. I'm not gonna be concerned about that for now. Okay, so I'm going to configuration, and also I have to set up my MQTT server. So I'll do that. Just let me pause it for a while. Okay, so I've done with my MQTT settings, and I'm just gonna change the topic name to water heater, so it'll be more obvious to know that this device is for the water heater. Okay. So now I think it's connected now. Let me see. It's connected to my MQTT server. That's great. Now let me connect it to the live mains of the water heater. So that's how to configure it from the web UI. Now I'll just disconnect the USB and assemble it back to how it was. Okay. Just align the screws here. So that's why I removed the board from the casing. I just like to connect the pins from the bit beneath the board. It's just easier. It applies automatic tension on the wires, and you don't need to hold it with your hands that way. So as I showed you in the previous clip. So I'll connect the rest of the, I'll just screw back the rest of the screws here. Sorry for my sloppy job here. Okay, the last one. Why do they have to make everything so tight? But this is nothing compared to S26, so it was very hard, so this is much easier. And apologies for my previous video, it's not very detailed. I really hated the way how I was flashing S26. I wish I hadn't gone for S20, it would have been easier. Anyway, so connect the casing. Okay, and we'll leave this to the end when we connect the mains. So one important note before doing the connections: the heater is on. That's dangerous. Just turn on the switch and turn it off from the circuit breaker. Turning it off, and now it's off. Let's start working on the wiring. So instead of cutting any wires, I'll just remove the original wire here, which is connected to the live wiring at my home. So I'm gonna remove this wire, connect it to Sonoff, and then from Sonoff I'll connect the output back to the heater. So I'll disassemble the heater now. I'll pause. So these are the wires. Probably this is the ground and the neutral and the load. So we'll connect them to Sonoff and remove them from the heater. The heater wires prepared here, all stripped and ready, and the source wires. Now I'm gonna connect them. So on the source wires, here's the Sonoff POW. I'm gonna connect to the ground. I think the order does not make a difference for input and output in ground, so it's gonna connect to the device anyways. So connecting them by pushing the wires, and this is supposed to be the input. So I'll put the neutral, connect the neutral to neutral in the input. Also the order does not make a difference, so let's connect them here. But I'll connect it to the far right one, just for the sake of making it easier. Let me know in the comments if you have any thoughts about the neutral and ground connections. So I'll connect the rest now. Load input. This is a very important point. So input and output of the load have to be proper. This is the input load, so I will connect it nice and firm here. This is the most important wire. Nice and firm. Okay. The next wire, the other ground, and now we connect the output load. And disconnect the other neutral wire. I think I have to strip it more, or it's fine, it's fine. Just let's connect the other load. The circuit breaker is still closed, so that's very important. Please keep it closed. Okay, nice and firm. Last wire, the other neutral wire. I think I have to strip it a little bit more. I'll pause here, and then I will close the box. Okay, so you can see here, Sonoff is turned on, heater is off. I'll just use the button here. Okay, heater is on, means everything is working fine. So let's close that box, and I'm gonna use a double side tape in the back to hang it to the wall here above the false ceiling. So that's it. Next maybe I'll show you Node-RED. I'm gonna do a small workflow where I'll just turn it on at a certain time and turn it off when the load is low. That means it completed a full cycle of heating the water. Alright. Close the box, and it's very tight actually. I don't think they have designed it for 2.5 millimeter wires, but it's fine. It's holding it in place. Fine. So I'll just put this double side tape in the top. So I could have put it this way, but my double side tape quality is not that good. So I'm just gonna stick it on top of the false ceiling itself. Okay, so it's sticked up on top of this false ceiling. I'll just do the Node-RED workflow and try it out. But for now, I can also test it through MQTT for now. I'll show it to you. So on MQTT dashboard, now we have the power reading, and this is how to set it up. Just you need to subscribe to this topic, whatever name you give to the Sonoff, tele in prefix, and sensor in the postfix suffix. Now also you need to handle the response. The response is in JSON, is a JSON object. So if you look at the message object. So the under energy attribute, the children of this attribute, you will find power with a capital P. So just configure that in the JSON and save it. Now you have your power reading. So if I turn on the heater, it should go up to 1300 approximately. Yeah, so this is working out fine now. Also on Node-RED, let's see how we can do some useful workflow on that. So one extra tip, you can just add postfix to the value, so it will make more sense on the unit of the value being displayed. So this is the Node-RED workflow that I have built for the water heater. Okay. So this is the flow name, water heater, and I've put the inject node. In the inject node, I specified the power topic, the command power topic to the power heater to turn it on and off. So I'm gonna do it every day at 5:30 a.m. to turn on the power heater. And once the power heater is on, it will automatically send the sensor reading for the power value. And I'm listening. I'm just debugging those values. This is just for another workflow also. These values are not related to this workflow. So I put a JavaScript function node also that whenever energy.power is less than 50, this is the payload that comes back from the sensor topic from the Sonoff. So when it is less than 50 watts, just turn it off. Otherwise, don't send anything. Okay. So, and the message gets propagated to the power topic of the Sonoff POW R2. So if I just try to turn off the power heater or turn it on, let's say, just turn it on. I'll turn it on from my mobile phone. So turn it on. Now there is the payload has been received that the power reading is, I think, more than 1000 something, 1266. So in that case, it will not send off to the water heater. So if I turn it off, the water reading will go back to zero, I think. So power is zero now. If the power is zero, it will send off. Basically, if the power is less than 50, it will turn it off. So what I want to do here is just turn it on every day at 5:30 a.m. and do a full heating cycle until the internal switch of the water heater turns off. You know, the water heater has a switch that works with the temperature. So whenever the desired temperature is reached, it will turn off the power from the water heater, and then the Sonoff will detect that the power reading is low. And then I will just turn off the power, the power source itself through the Sonoff. So it will not keep on heating the water again and again. I don't need that. So this is one way to do it. Maybe you can explore to do some other ways. Thanks. Let me know in the comments if you have any suggestions, or you want to receive some other type of videos to explain more in depth about maybe Node-RED or Raspberry Pi, or the setting up Node-RED on Raspberry Pi, or setting up Mosquito for the MQTT server. We can explore, see whatever you want to create. Thanks. So one more recommended setting is to go to console and type power on state space 1. This will result in that whenever you turn on the Sonoff from the main on switch, then you will find the heater always turned on, and then my logic in Node-RED will work that it will turn on until the power goes to less than 50 watts, then it will turn off. So this is useful so that you can still make use of the physical on switch on the wall. So I'll give you an example here. Here, if I turn on this switch, I will see that the heater is turned on directly. So this is useful to make the switch still in usable status, right? Otherwise, if you just turn on the switch, it uses the power retain, and if it was off, it will keep on off. It will not turn on when you turn on the switch. So that power on state command is very useful. Just don't forget that. Just one more tip: go to configuration, others, and set it to belkin wemo, so you can, and give it a friendly name, so you can you can control it over Alexa. So in Alexa, you can have this smart plug. When you start to discover devices and Sonoff is on belkin wemo emulation mode, you will find it under smart plugs in Alexa. So you can tell it, for example, turn water heater on and turn water heater off. I think my internet is a bit slow for now. I'll show it later. So here you can see the water heater is identified as a plug because of the belkin wemo emulation. So that's all for Alexa.